Welcome to Fanshawe College. Welcome to the lab. This week is the orientation week. We do not go to the lab yet, but we will watch this video to learn the lab rules and the basic lab requirements. After watching this video, you need to complete a short quiz to obtain the mark for Lab 1. This video includes 4 parts. 1. Introduction. 2. Lab rules. 3. Lab plan. 4. Demo of Lab 2. Let's move on with the introduction. What is the number 1 concern in the lab? Your answer is safety. Correct. You are not going to do such things as shown in the picture, right? Your promise. Everyone knows, safety is number 1. However, sometimes we still see these things happening. Let's think together, why does accident still happen? The possible reasons may cause accident are 1. Not prepared. 2. Not paying attention. 3. Not following the rules. Logically, how can we prevent accident in the lab? 1. Be prepared before the lab. 2. Pay good attention during the lab. 3. Always follow the rules. What does it mean by being prepared? For every lab, we should do the followings. 1. Print out the lab instruction from Fanshawe Online. Here is an example. 2. Complete the preparation portion. 3. Read through the instruction to get the overview of the lab. What does it mean by paying attention? Follow the lab instruction step by step. Learning by doing. What does it mean by following the rules? We need to follow the lab rules carefully. Let's take a close look on our lab rules. We need to protect ourselves in the lab. But do we need to dress up like the man in the picture? Not necessary. Our lab rules are 1. Follow your lab schedule. 2. Bring your lab kit. 3. Wear safety glasses. 4. No food and drink. 5. Prepare. 6. Pay attention. 7. Follow instructions. 8. Tidy up the station after lab. We believe every one of you will follow the rules to keep us safe in the lab. Now the lab plan for the semester. This course plan is posted on Fanshawe Online already. First lab is the introduction. By watching this video, you collect the information and get ready for the semester. Starting in week 2, we will do 8 labs, which gain 15% of the mark, and 2 lab tests, which gain other 15% of the mark. If you lose 1 lab session due to the study break or holiday, your lab schedule is shifted by a week. Please be advised that all the labs and lab tests are mandatory for passing the course. Please follow your lab schedule to complete the labs on time. If you need to miss a scheduled lab because of some important reasons, please contact your lab instructor ahead of time and work out a catch-up plan. Now let's take a look at the next lab, Lab 2. Before coming to the lab, please print out the lab instruction from Fanshawe Online. Then write your name and the date of the scheduled lab session. Then complete the preparation portion. The answers to these questions can be found from the earlier presentation in this video. When you come to the lab, ask the instructor to check your preparation and sign. Each student will have your own lab station. At your station you will see 3 devices stack up. On top is a signal generator. We do not use it in this semester, but we will use it next semester. The next one is an oscilloscope, which is used to show the signal waveforms. We will learn how to use it in the future courses. The last one is a DC power supply, which we will use in all of our labs. Let's get to know more about it. The DC power supply has 3 output channels, 1 channel of fixed 5 volts, and 2 channels of adjustable voltage. Here are the 2 terminals of the fixed 5 volts channel. The red one is positive and black is negative. Here are the 2 terminals of one adjustable output channel. Its voltage range is from 0 to 30 volts. The 2 meters above display the outputs. The left one shows the voltage and the right one shows the current. Here is the second channel of adjustable voltage channel, same 0 to 30 volts range with 2 meters above. To adjust the output of an adjustable channel, 3 knobs are used. The first one is for voltage course adjustment, the middle one is for voltage fine-tuning, and the third one adjusts the current limit. We will get more familiar with it when we use it in our future labs. Now let's get to know our digital multimeter. People usually call it DMM. You can find it in your lab kit. A DMM is used to measure different kinds of electrical variables. The central dial switch is used to select the functions. The dot on the handle shows the function of selection. We can see the following functions: continuity, diode, resistance, range 200 ohms to 200 mega ohms, DC voltage, range 200 millivolts to 1000 volts, AC voltage, range 2 to 600 volts, temperature, frequency, unit Hz, AC current, range 20 milliamps to 10 amps, DC current, range 2 milliamps to 10 amps, capacitance, range 2 nanofarads to 100 microfarads, transistor amplify factor HFE. In the next lab, we will practice measuring the first 3 functions: continuity, resistance, and voltage. There are 2 probes to be connected to the DMM. The black one is always connected to the terminal, COM, at the bottom left. The red one should be connected to different terminals according to the functions. For measuring voltage V and resistance ohms, the red probe is connected to the top red terminal at right. For measuring smaller current in milliamps, the red probe is connected to the top red terminal at left. For measuring bigger current in amps, the red probe is connected to the bottom red terminal at right. Please follow the instruction very carefully when you start learning how to measure the current. Otherwise you may blow the fuse of your DMM. Another useful tool in your lab kit is the breadboard. The breadboard is a platform for quick building an electrical circuit. We will use the breadboard to build our prototype circuit and run the test on it. All the pins on a breadboard are pre-connected following certain rules. We can see 4 power strip rows, PT, NT, NB, and PB, where all the pins in the same row are all connected. The pins in different rows are not connected. Then we have 2 half matrix. The top half holds rows of F, G, H, I, J, and columns of 1 through 63. The bottom half holds rows of A, B, C, D, E and columns of 1 through 63. In each half matrix, only the pins in the same column are connected. The pins in different columns are not connected. The pins in the top half are not connected to the pins in the bottom half. In the lab you will verify all these connection rules through your own hands-on experiment. That's all to be presented in this introduction video. I hope you enjoy watching it and have learned how to prepare for future labs. You still need to complete a short quiz called Lab1 on Fanshawe Online to get your Lab1 mark. I hope you will continue to enjoy learning electrical theory through hands-on labs.